Hello everyone, today in this video we'll be discussing the first module of computer networks, which is data communication. So it has mainly 5 topics which we'll be discussing in depth, and if you watch this video till the end, easily you can score more than 80% marks. And make sure you hit the like button, subscribe to my channel for more videos like this. Without wasting any more time, let's get started. The first topic is introduction. So let us get started with the term data communication. So what is data? Data is some information which is present digitally, and communication means transferring from one point to other point, right? That is what is called communication. So data communication is the exchange of data between two devices via some medium. Okay, so there is a medium through which we'll be transferring the data from sender to receiver. That is called as data communication. Now there are 4 fundamental characteristics. Very important question from exam point of view. There are the first one is delivery. Delivery means the whenever a communication is happening, it should ensure that the data is reaching to the specified destination. Okay, that is important. Second is the accuracy, means it should not be altered in between. Timeliness means it should arrive at the proper time. Jitter means it should have a proper order in which it is arriving. Okay, so these are the 4 fundamental characteristics. Apart from that, we have the next important question, which is the data communication system. Okay, our data communication system has 5 components. Which are those 5 components? That is an important question. So you have to make this diagram here. So as you can see, the 5 components are: first, let's start from the message itself. What is a message? It is the information or the data which is to be communicated. Okay, so some of the forms include the text, numbers, pictures, audios, and video, right? So this is the data which is going to be transferred, and for transferring the data we need a transmission medium, right? In the transmission medium we will be using to transfer, it can be either the wires, or it can be the radio waves, or it can be some other mode of transportation. And we are transferring the data from the sender to the receiver, and there are some protocols to be followed. So protocols basically means rules. Okay, which rules we have to follow, that is called as a protocol. The rules which govern the data communication. Okay, next we have the 5 forms of data. Okay, this is also very important question. What are the different 5 forms of data? Text data. Okay, text data consists of the ASCII characters, the 127 characters in Unicode, which is comprises of letters and numbers. And those kind of data is called as text data. And numbers we have that are also represented in the ASCII, but it is slightly different. Next we have the images, which are stored in the form of pixels, in the form of RGB or black and white or grayscale. So those kind of data. And audio data is also transferred, that is also coming under the data. It is the recording or the broadcasting or the sound of music, those kind of data. Okay, and video is nothing but a continuous flow of images in a very fast pace. It also has frames. Okay, so how many frames are being changed, how many images are being changed per second? In that form, if we transfer the data, it is called as video data. A very important question from exam point of view. Next, we have the data flow between the devices, that can be of 3 types. This is also a very important question. What are the 3 types of the data flow? The first one is the simplex data. What do you mean by simplex? As you can see, the direction of data is single here. Like, it is getting transferred from the source to the destination. It is unidirectional. The data cannot be sent back from monitor to mainframe. Okay, that is called as simplex mode. The next is half duplex mode. In half duplex mode, it is possible to send both the data from this side as well as this side, but not at the same time. It can send this data at time 1, and it can send this data at time 2. Okay, like that it will be. That is called as half duplex. Next is the full duplex. This is the most of the data which we are using in today's times. It allows the data transfer from both directions at the same time. Okay, that are the 3 types of data flow. The next topic, out of the 5 topics which I have told, the next topic is the network. Okay, so what is a network? It is a set of devices that are interconnected and capable of communication. Okay, if a couple of devices interconnect with each other so that we can transfer the data in between them, that is called as a network. So in network, you need to remember 3 things. There is a network, and there is a connecting device, there is a host. Host is the end device which we use, like a computer or mobile device. Connecting devices are the ones which facilitate the transfer of the data from network to the host, like router or modem. And network is the one which is the source from where the data gets started. Okay, there are 3 criteria for a network that must meet: the performance, reliability, and security. Means the performance can be measured in many ways, including the transit time and the response time. So how well it is responding. And 2 main things are throughput and delay. Okay, throughput and delay. Throughput means how much data is getting output per second, and delay means how much data is how much time it's taking for our data to get transferred. These two are very important factors which are seen in performance. Next is reliability. Reliability is measured by the frequency of failure, how many failures are happening and how the program is recovering from the failure. That is called as reliability. That should be very fast. And security means if the system is not allowing the unauthorized access and it's blocking the virus and the people who are not eligible to access the system, for them it is not allowed, those kind of things are present or not, that is called as security. So our network should ensure performance, reliability and security. Okay, and there are two types of connections, linked and the point to point and multi point. Point to point, as you can see, it's connected between two systems, and multi point also connected between two systems, but in between there are different systems present which take the data from the same link. Okay, and there are four basic topologies. This is also very important question from exam point of view. What is a topology? See, I have many devices. Okay, so all these devices are interconnected with each other, and all are not interconnected in the same fashion. There are different ways of interconnecting it. So we have the four ways. The first one is the mesh topology. What do you mean by mesh topology? In mesh topology, all the devices are connected with each other. Direct connection is there between every other device. Okay, sorry, I had forgotten to make this one. This one is also present here. Okay, so this is the one which has the direct connection with all of the other devices. So the disadvantage here is that it requires a lot of wiring, and it requires like suppose I want to transfer the data from this to this, and this single wire is broken. At that time we will not be able to transfer the data, right? Because this is the only connection present between this and this. So that is a disadvantage, but it is faster in transferring the data once it's set up. The next is the star topology. Star means it's interconnected with a hub. Hub is the like a main server, a single point from where the data gets transferred to the devices. This is called as star topology. And here the disadvantage is that if the hub fails, every other system will fail. But if any one system fails, the other system will still remain working. Okay, that is the advantage. And next is bus topology. Bus means there will be a link present here. This is the end, this is the start, and the data will be transferring, and whichever computer requires what data, it will take it. Okay, next one is the ring topology. In ring topology, we will be interconnecting all the devices, and suppose the device A, this is device B, and if A device wants to transfer the data to B device, it will first transfer to this one, and then this one, and then it will transfer to B. Like that it is connected. But the disadvantage here is that if one of the line is broken, we cannot transfer the data between any of the systems. Otherwise you have to go into the other way, long way around, right? So this is the disadvantage. It is interconnected, so a single point of failure exists here. Okay, so very important question. Four types of topology: mesh, star, bus and ring topology. Next we have two types of network: the local area network, also called as LAN, and wide area network, also called as WAN. Okay, so what is the difference between them? It is related to the size. Okay, a local area network is usually privately owned and connects some hosts in a single office or a building or a campus or some area. Okay, a small area, if it's interconnecting all the devices, that is called as a LAN. The wider definition of it is the WAN, where we have the wide area network. It can connect the whole city. Okay, so this is the difference. And in WAN there are three types. The first is point to point WAN, where we'll connect one network with the other network. And second is the switched WAN. We'll be having different switches present here, so that it will interconnect with the every other network. And internetwork, also known as internet, the small I, this is a different internet. Here what will happen is one LAN will be interconnected with a different LAN. Okay, this is suppose that an office has its west coast and east coast. If you want to connect the west coast with east coast, it will take a router. It will make a connection using WAN, point to point WAN, and this whole data will be getting connected with this whole data. Okay, so this is called as internet. Okay, or internet network. And if this same thing is taken at a very large scale globally, it is called as the internet with capital I. Okay, this is a small I, different internet. Next we have switching, which is a process of managing and redirecting multiple links. See, once we transfer the data from one point to the other, it will not be through a single link. Okay, we are representing it via a single link, but eventually you will be seeing in the upcoming topics that there will be many links present. And which link should be transferred for which data, that is handled via a process called switching. Okay, so two types are there: circuit switch network and um, actually packet switch network. Okay, so circuit switch network is a circuit that will always be available for two end systems. Like for example, here the diagram is given. So the circuit switch network, here we have a switch and here also we have a switch. So these are the telephone lines. Okay, like for example, in city A there are 4 telephone lines available, and city B also there are 4 telephone lines available. And if everyone comes to these telephone lines and calls to their loved ones here in the other city, what will happen is the connection will be made between this telephone and the respective telephone which they are trying to connect, and this all will be happening simultaneously, and the data will not be mixed because it is a high capacity line. So this single connection exists between this and this particular one, and this particular one, and so on. Okay, so this type of network is called as a circuit switch network. Next we have the packet switch network, in which the data transfer happens in the form of packets. So we'll be dividing the whole data into different packets and transferring their packets one by one. Okay, so the packets will be like in a queue, and it will be transferred via a router. This is called as packet switch network. And let's see how the internet looks like today. So internet looks like this. Okay, so observe this diagram carefully. Here you can observe three levels. The first is the customer level, like we, the end users who use the internet in the devices. That is called as a customer level. Next, we have the provider network, which is internet service providers. Those are the ones like Airtel, Jio, and Reliance. All those are the provider networks. They will take the networks from the backbone. Who are the backbones? Backbones are the ones which actually set up the data lines in the between the continents. Like for example, if this is Asia and this is Africa, between Asia and Africa there will be ocean, right? Inside ocean they will be setting up a cable here. The company which sets the cable is called as a backbone. They are the international service providers, and the ones who set up the internet within the region, like within Asia or within India, within Bangladesh and so on, those are called as provider networks, and they provide us with the data. Okay, so this is a three-level process. So backbones are often referred to as international ISPs, and provider networks are referred to as national or regional ISPs. So Airtel and all is regional ISP. There are four ways to access the internet: using telephone networks, using cable networks, using wireless networks directly connecting to the WAN, or direct connection to the internet, means becoming ISP yourself, internet service provider yourself. They can access the internet. Okay, so these are the four ways you can access the internet. The third topic from our five topics, the third topic is the protocol layering. So protocol means what? Rules. Okay, so now we are going to understand how exactly the communication happens. So a communication happens between the source and the destination. Let's suppose Maria is the source and Anne is the destination. Now Maria is talking to Anne here, so the communication medium is air, and direct communication is happening between them, and they live in the same locality. Now suppose that Anne has shifted to some other city. So how will Maria talk to Anne? Maria will talk to Anne using a mail, right? So she will be writing a post, and the post will be transferred and sent to Anne. Now the post is also need to be encrypted. Why? Because if the postman reads the Maria's mail for Anne, then it will be not good, right? So that's why to avoid that, Maria will be encrypting it. Okay. So what is encryption? That will be converting the text into a different unreadable format, and which can be decoded only by Anne. Okay, so there are different layers here. See, normal talking is the first layer. They used to talk normally, right? But now since they are living in a different location, first they have to encrypt the data, then we have to send the mail, and the mail gets transferred in this layer, and then it gets decrypted, and then the Anne will be able to uh, get to know what Maria has written in the letter. Okay, so this is the three-layer protocol. So each of this is called as a layer. Okay, so in real time also we'll be passing the message through different layers. Will not be directly transferring. Like we assume that when we send a WhatsApp message to someone, it goes directly into their phone. It's not going directly into their phone. It's passing through many layers. We'll be having a look at what those actual layers are. Okay. So there are two principles for the protocol layering. The first one is each layer should be able to perform bidirectional task. Okay, what do you mean by bidirectional task? Suppose Maria sends a letter to Anne, and Anne will read the letter and send back to Maria. If she sends back to Maria, Maria should also be able to decrypt the message along with the encryption, right? Same goes for here also. The encryption and decryption both should be the skill set of Maria and Anne. So in each layer, both the kind of thing should happen: sending and receiving, encryption, decryption, and listening or saying. So you get my point, right? So both the things should be there in each level. Okay, and the second one is objects in each layer at both sides must be identical. That means at this layer, at the top layer, there should be only listening and talking. It should not be like listening and talking here, and here it is sending mail. That will cause a conflict, right? So it should be having the same thing here, the step by step process. First, draft the mail, then encrypt it, then send the mail. After send, first receive the mail before decrypting it, because you cannot decrypt unless you receive the mail, and you cannot check the mail unless you decrypt the mail. So it should be like a order, like a proper sequence of steps to be followed in the both directions. Okay, that is the second principle. So while forming the layers, this should be kept in mind. Okay, so there is a logical connection between the peer layers. Since now we know that there is a different layer and it happens step by step, but it happens so fast that we assume that when we do the send the message, it gets received here. So we can assume that it is happening via imaginary line present here. That is called as logical connection. And encryption happens, decryption happens. Very fast it happens, and send mail and gets received in the other end. So that also happens very fast. So we can assume that there is a logical connection between each layers. Okay, there is a what? Logical connection between each layers. Okay, next we have the important, very important concept, the TCP IP protocol suite. So now we will be seeing what actually are the layers present. Okay, so we have 5 layers present in real life. The first layer is the physical layer, second is the data link layer, then the network layer, then transport layer, and application layer. Let's have a look at what all each of these terms mean. Okay, so communication through the internet happens via these things. Source A. Okay, let's take an example. I am using Instagram to send a message to my friend. Okay, so that will be my application layer. I am sending a message. Now the message will be going to transport layer. What does transport layer do? It will check if the message is important one or not important one. What do I mean by important or not important? Important means in any form there is no chance it should be damaged, and it should be transferred very securely, like bank statements. That is a very secure one, but the messages which I send, that is not that level of security is required. So that are the two categories. Okay, based on the two categories it will decide is it important or not important. Important means it will take some time, it will do the security checks and all, and it will secure the message, then it will send. If it is not important one, it will just send, and most probably will be receiving unless some hack happens in between. Okay, so it will select this one, either the important, not important, and then that message will be sent to network layer. Okay, inside the network layer we will be able to get a connection between the sender and the receiver. My friend uses an iPhone, I use an Android, so a connection will be made between Android and iPhone, and then the message will be sent to the data link layer. In data link layer it will be either LAN or WAN, like which kind of Wi-Fi you are using. So that Wi-Fi thing will be verified here. After that we will come to the physical layer. Physical layer is the actual one, the wire from where the data will be transferred via the optic fiber, coaxial cable, or via the Wi-Fi or the routers. Whatever is the form, it will be transferred via the physical layer. So it will go to the physical layer like this. It will switch to the data link layer and verify the connection. It will come back here. Router will check the network, and again it will come back. In the destination side also it happens the same thing, and then again it will come back to the destination one by one. First it will come to the physical layer, it will go to the data link layer, and it will come to the destination. It will check if it is important or not important. It will take the message and it will decapsulate and send to application. What is decapsulation? I'll discuss in a while. Okay, so this is the way how the data gets transferred from source to destination. Okay, and this is the simplified diagram from A to B. If you want to transfer, there is a link in between and there is a router. So this is the router in between. The link consists of this thing. This is the links, and whichever the destination wants to go, it will go to the destination via the particular link. Okay, next we have the layers in the TCP/IP protocol suite we just discussed. Application layer, transport layer, network, data link layer, and physical layer. Just a different kind of representation. There is a logical connection between each of these layers, as we had already discussed in the previous topic. That we can assume that it's having an imaginary line between the application and the transport, network, data link, and physical layer. Okay. Next, we have the identical objects in TCP/IP protocol suite. Identical objects should be there, so that principal is getting verified or not. Application, this is also application layer, and here we have transport layer, which sends the segments or the user datagrams. So that is the transport layer. And in network also we have the datagrams. In data link we have the frames. Here also we have the frame. In physical we have the bits in which the data is getting transferred. So this is called as physical layer. And all these things are same in both the sides, so it is called as identical objects, and the principle is verified. Okay, let's dive deep into the physical layer. It's a very important concept. So what is a physical layer? It is the lowest layer and it carries bits. Okay, it carries the bits like zeros or ones in a frame, and the two devices are connected via cable or air. Okay, wire or wireless. Okay, Next is the data link layer. Internet is made up of LANs and WANs, right? Internet is what? LANs and WANs, and the datagram travels through the various links and routes. Okay, so the data gets transferred via the links and routes, so it is called as the data link layer. And the data link layer's responsibility is to choose the best route for the datagram. Data wants to be transferred from A to B. What is the best point I can use? That is identified by data link layer. Got my point? What does data link layer do? It will choose the best route for transferring the data from source A to destination B. Next, you have the network layer. It is used for creating a link between source and destination. The network link, okay, like the Wi-Fi one or the cable one. The link is handled by the network layer, and the main protocol is IP, which is Internet Protocol. We see that IPv4, IPv6. So those are the formats in which we represent. So it will have the information of the source and destination address and the data and the timing and the users. All those data are present in the IPv4, IPv6 format. So this data is also transferred along with the original data via the network layer. And in the transport layer, it encapsulates. Encapsulate means it covers the data with the headers. Headers will have some metadata, okay, and it will transfer to the next layer, which is the network layer. Okay, if it is coming from the application layer, it will come to the transport layer, it will go to the network layer. Okay, so transport layer does that. And there are two protocols used, TCP and UDP. TCP, very important, transmission control protocol. Okay, so it is called transmission control protocol. Here we will be making it more secure. It will be having the request sent and the acknowledgement is transferred, and the secure connection is made in between them, and it's verified that the connection is working fine. And once the data is getting transferred, it will send back a message that I have received the data. This is all ensured for more security. Okay, so that is called TCP. UDP is the way in which it is more faster, but it will not ensure anything. It will just send the data and there is no acknowledgement that it has reached or not. We will not know if it's reached or not. So this is used when the people spam the mails, right? They just send the mail. They are not concerned about whether it reaches the destination or not. But if you want to send some bank data or password data, it should be very important to ensure it has reached the destination. Okay, next we have the last layer, the topmost layer and the most important one, which is the application layer. It is a source and destination of the data information. Data comes from the application layer and goes back to the application layer, and there we are there, which are the end users. Okay, so a few of the protocols which are used is HTTP, Hypertext Transfer Protocol, used for the websites. SMTP, Simple Mail Transfer Protocol for the mails. FTP is the File Transfer Protocol for transferring the file data. And these protocols define how the data is to be formatted and what data needs to be sent, what is the metadata needs to be added, which is valid, invalid data. All those things are decided by the protocols, and it's specific for the applications. Like for web it is separate, for mail it is separate, and file it is separate, and so on. Okay, there are different types of addresses used. Okay, what do you mean by address? Address is nothing but, in the application layer we have the names. For each message we have a name, and for the transport layer, for each message we have the port number. For the datagram or the network layer we have the logical address, and for the data link layer we have the link address. Why don't we have anything for the physical layer? Because it's directly connected, we need not have any address. See, we need address because we want to know where to transfer the data, right? If it's directly connected, obviously it's going to be transferred here, but from here where it's to be transferred, there will be n number of possibilities. So it will be identified via the address in each layer. Okay, and this address data is also coming as a part of message. Okay, what is multiplexing or demultiplexing? Multiplexing means in each layer we'll be transferring different types of data. So like for example, if I choose a protocol and transfer the data, I'll be multiplexing it as TCP, right? I cannot transfer the whole data like this. I'll be categorizing it as TCP, and if I send via this one, I'll be categorizing it as UDP, and this is comes under IP. So only IP will be sent with the other information present inside it. Okay, so this will save the uh, like the memory, right? Instead of sending all the data, we are just taking the needed one and putting inside the main file. And it also helps us with modularity, where we are putting all the important things and the connected things in one single place. The opposite of it is deep multiplexing from IP, which one you are using, TCP or UDP. From TCP, which one, if UDP, which one. Okay, that is called as multiplexing and demultiplexing. Next, we have a similar kind of model, open system interaction, also known as the OSI model. Okay, in OSI model, what happens? In OSI model also everything is same, except that presentation and session layers are different. If you observe carefully, physical was there, data link was there, network was there, transport was there, application was there. The addition is presentation and session layer. But if you ask me what is presentation layer and session layer do, what are the protocols, that is not totally defined, and that is the main reason why it was not successful. So what happened is, when TCP/IP had come out, at that time all the setup was done in using TCP/IP for all the computer systems and everything. So what happened after that, OSI also came at the same time. But since the setup had already been done for this one, the money has been spent, time has been spent, setup was done, we cannot replace again with OSI model. And also another disadvantage is that presentation and session layer are redundant. We need not require it. And also if we are required, it's not defined what it actually does. Okay, till now it is not defined. So that's why OSI was not successful, and still we use TCP/IP all over the world. Okay. Our fourth topic from the five topics is transmission media, also known as the physical layer. In physical layer, we are using the transmission media. That is the main layer from where the data gets transferred, right? So let's have a look at what the important topics are. So transmission media is something that can be used to carry information from the source to the destination. Okay. So this is the diagram. In the diagram, we have the physical layer, and its sender, here is receiver, and it goes to the transmission medium like cable or air. It transmits the data and receives at the receiver side. Okay. And there are two types of transmission media: guided and unguided. As you all know, the guided means wired, and unguided means wireless. In guided, we have twisted pair cable, coaxial cable, and fiber optic cable. Here we have radio, micro, and infrared waves. Okay, let's have a look at each one by one. First one is the twisted pair cable. In guided media, we have the first one, twisted pair cable. So it is the first cable made when transferring the data via wire. Okay, so here as you can see, there are two wires interconnected with each other by twisting it, and this is the copper wire, and this is the rubber one, rubber or plastic. Okay, so this is the insulator. So inside this there are conductors are there. Now you may ask me why there are two wires. So one wire is used for transferring the data, other is used for ground reference. So what is ground reference? It's just for the balancing purpose. If some interference happens here, it will do the opposite effect of it, so that data is intact, it's not out of balance. Okay. And what is the connector used here? RJ45, which is a register jack. You might have seen when you plug in the projector into the laptop, at that time this kind of thing will be pressing from here, and you'll be entering here in the RJ45, right? So that is a UTP connector. Okay. And the performance is based on frequency in the twisted pair coaxial cable. Here we'll be measuring the performance in the form of gauge. Okay. And the diameter is also given, you can go through it. Attenuation is in the form of decibels per kilometer. How many decibels are lost per kilometer? Attenuation means loss of data. So as you can see, as the frequency increases, the loss is also increasing. Okay. So this is the performance aspects of twisted pair cable, and they are mainly used in the telephone lines. Moving on, we have the next one, which is coaxial cable. Coaxial cable carries frequencies of higher ranges, more than the previous one. It carries the frequencies. Okay, and this is the structure of it. Here we have the plastic cover at the top, then we have an insulator, and then we have an outer conductor or shield, and then we have an insulator inside, which is the inner conductor. Here the data gets transferred. Okay, and the coaxial cable is categorized as different ratings. RG ratings are given to it, the radio government ratings, and the impedance is given for each of these. It can be cable TV, thin Ethernet, or thick Ethernet. Okay, so different category names are there. And it also uses a connector which is BNC, Bayonet Neil Conselman connector. Here we have the BNCT connector. The BNCT connector gets connected here, and this one gets connected here, and this is connected to the ground wire. Okay. The performance aspects of which is that it's having higher attenuation, means more losses than the twisted pair cable, because it's having a higher bandwidth. It's obvious that if the more data is transferred, there will be more losses, right? And this is the graph for it, you can go through it. And the application include the telephone, and it's very high range, like 10,000 plus voice signals can be transferred at a single given time, and the digital data can also be transferred 600 MB per second. Okay. Next, we have the fiber optical cable, the last one in the guided wire media. So here it is made of glass. Okay, what is fiber optic cable? You have studied in the first semester physics. So it is a wire here made of glass, inside which the light gets transferred like this, and this gets transferred via the principle called total internal reflection, where the reflection happens after touching the surface here. It gets here, it gets here, and so on. It goes. Okay. So this is the working principle of fiber optic cable. And it also has the cladding and the core. Core is the one where the light gets transferred, and from the sender to the receiver there are two modes are there. the multi-mode and single mode. Single mode transfers one data, multi-mode transfer different data. Those are divided into step index and graded index. In step index, we have the data in the form of sharp reflections. Okay, so the cladding and the core's densities are constant, so that sharp reflection happens. But graded ones vary in the density, so that a smooth reflection happens. Okay, so that is the difference between multi-mode step index and graded index. Single mode will just transfer it in a straight path. Okay, and it will be very small also diameter. As you can see, the diameter is big here, the diameter is small in single mode, because here multiple data needs to be transferred, and here only single data needs to be transferred. Okay, and it has three types of connectors: SC connector, ST connector, and MTRJ connector. You might have seen this one in while plugging in the TV, and this one also while plugging in the Wi-Fi, right? So those are the ones which are used mostly in our daily life, the fiber optic cables. Okay, and this is the performance of the optical fiber. As you can see, between the lengths wavelength 1300 and 1500, there is a high level of loss. Okay, so there is a loss at this point. Otherwise it is fine. Okay, the loss is manageable, but in between this wavelengths it is a very high loss. Okay, so the reason is not given. I'm also not sure. You can research about it for knowing more information about it. And the application include most of the data transmission in today's time. Whatever data is getting transferred, even now you're watching this via YouTube, and this data is getting transferred via some ocean through optical fiber cable. Okay, next we have the unguided media. Three are there. Unguided means electromagnetic waves are used in wireless communication. As you know that electromagnetic waves comprises of different forms of waves, which are having the different wavelengths and frequencies. So let's have a look at what range of frequencies can be used for the wireless communication. Okay, so the range of frequencies which are used for the wireless communication is starting from 3 kilohertz and goes up to 900 tetrahertz. Okay, so this is the range for the light wave which are visible to the human eye, and the infrared waves from 300 to 400 tetrahertz, and this is the radio wave and the microwave. Okay, so we'll be learning about the radio wave, microwave, and infrared waves, by using which we can transfer wirelessly. Okay, so there are three propagation methods: ionosphere, ionosphere, and okay, so this is the ionosphere given here, and this is a ground propagation, sky propagation, and line of sight propagation. Okay, so the ionosphere travels via the close to the earth. Okay, like that it will travel, and wherever it wants to be received, it will go and get received there. Okay, and ionosphere travels via the sky like this. Okay, and line of sight means it should be a straight line here. Okay, that is a three ways of propagation. The next we have the 8 bands of EM waves: very low frequency, middle frequency, high, very high, ultra high, super high, and extremely high. Okay, ranges are also given here. The propagation is either ground, sky, or line of sight, and the application are the radio waves, the aircraft, the FM radio, cellular phone, satellite, radars, and so on. Okay, based on the frequency, we are defining the range and the mode of propagation. Okay, so you can divide the wireless transmission into three: radio wave, microwave, and infrared wave. So let's have a look at what do these terms mean. Okay, so a radio wave will be having the frequencies in the this range, the range of we discussed here. The radio wave will be having the frequencies from 3 kilohertz to 300 gigahertz. Okay, so the wireless transmission is divided into three types: stereo, micro, and infrared waves. In a radio wave, we have the unidirectional wave. It ranges from 3 kilohertz to 1 gigahertz. Microwave is also unidirectional, 1 to 300 gigahertz, and can be focused at a point. That's why you use it for the heating purpose, because the waves can be focused at a single point. Infrared waves is used for short communication, and the range is 300 gigahertz to 400 terahertz, and it cannot penetrate walls. The infrared application is in the wireless mouses and the TV remote and the TV, right? The red light comes, so that is the infrared wave. Okay, next we have the packet switching. Okay, this is the last topic from the 5 topics, and it has two categories: the datagram network and the virtual circuit network. Okay, so what is the packet data transfer? Packet data transfer means that the data is transferred in the form of packets. It has two categories. The first one is the datagram network. Okay, so let's have a look at the datagram network. In the datagram network, okay, Datagram network treats each packet independently. Okay, that is an important concept. It treats each packet independently and it transports the packets via different routes. Okay, so different routes are present via which it will transfer the packet. Okay, also our datagram with the four switches are given here. So observe here carefully what's happening. So this is the source and this is the destination. Okay, so A is the source, X is the destination. The data is divided into different packets, 4, 3, 2, 1, and the datagram network is present here and it transfers in the to the destination. And here we have the different routes present here, or the switches present, and each of these packets transferred via a different route. See, this is getting 3 and 1 transferred here, 4 is transferred from here, 2 is transferred from here, and eventually everyone reaches here. Okay, so this is the datagram network, and the transfer is faster because multiple routes are being used. Then we have the routing table, which is used to determine the destination point. So destination port. So each of these packet want to know where it has to go eventually, right? So that is found by the routing table. In routing table, we'll have the information of where the data needs to be transferred. So see here, this is the destination address, the output port, it should go to this port. Like that, eventually where all it should go, that is being specified here. This is the port 1, port 2, port 3, port 4. So from here, if it comes, it has to go to which port, 4, 3 or 2 to reach the destination, that is specified by the routing table. Okay, and what is the delay present in the datagram network? Delay is greater in datagram network than in virtual circuit network. Okay, the second one, the first one has a greater delay than the second one. So why is it that the case? So it is because their transmission time. Okay, first it starts and does the transmission of the data, it waits for some time and does the transmission again, then waits for some time, does the transmission again. So total delay can be written as three transmission are there, first transmission, second and third transmission. Three transmissions are there. Okay, three transmissions are present, and waiting time are two. This is one waiting time, this is second waiting time. Two waiting time plus three transmissions are there, and also we have the propagation delays. Okay, for each of the transmission time there are propagation delays also. So 3t transmission time plus propagation delay plus the w1 plus w2, which is the waiting time. Okay, in between them. So this is the total delay. Moving on to the virtual circuit network, here we have the mixture of circuit network and the datagram network. Okay, so it's a mixture of circuit network and datagram network. There are some similarities in between them. So resources can be allocated in the setup and tear down phases. Okay, so in the virtual circuit network there is setup phase and tear down phase. In the datagram network there was no setup or tear down, it was just starting the transfer and ending the transfer. So here we have the tear down and setup phase. Also the resources are allocated during the setup phase, or it can be during on demand like datagram network. So both the modes are available in the virtual circuit network. It is packetized like the datagram network, and like circuit all the packets follow the same path, and VCN is implemented at data link layer. Okay, so the virtual circuit network, it's implemented at data link layer. Circuit network is implemented in the physical layer. Datagram network is implemented in the network layer. Okay, and the following diagram shows the VCN. So virtual circuit network looks like this. Okay, so here we have the different switches present in between, and the end systems are present. So data gets transferred from this via these switches. It goes here, 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 and it goes here to like this, and from here to here. Okay, so this is how the virtual circuit network works, and there are two types of addressing: the global addressing, where all the nodes know where to go at the end, all the packets know, and virtual circuit identifier is the one where after it reaches a switch it will get to know next which switch it should go. Okay, so these are two types of addressing used. Next we have the delay. So in this, the delay is first setup time will be there, it will go and acknowledge and it will come back. So it is more secure type of connection where the request is sent, acknowledgement is done, after then only the transmission will start. Okay, and transmission delay is there, three transmission delay, and waiting time is not present here, but tear down is present here. Okay, so these are the total delays. Okay, so total delay will be equal to 3t plus 3 pi 3 tau and setup and tear down delay. Okay. So these are the important questions from the exam point of view. Make sure you like this video and subscribe to my channel if you found this video helpful. And thank you so much for watching. I'll see you in the next one.